turning into exciting topic, another big one, artificial general intelligence. Okay, how close are we? AI is still a lot of math. It's still a lot of human help. It's a lot of work, as you know, to start the AI initiative, right? To progress and to reach results, to demonstrate results. So I'm in, again, very practical, very, I would say, business-like terms. AGI, is it already here?
Yeah, so as you said, I think very rightly, like a lot of acquaintances or a lot of our interactions with artificial intelligence is not as smart as we would like it to be, even now. Like when it comes to AGI, it's a more general representation of or more close to human thinking. Like if we can, like have something with a lot more human cognitive abilities or skills, and when they are generally faced with some task that is unfamiliar to them, they would still be able to, like work it out and find a solution, like basically we humans do every day in our lives. So it's, as you said, it's still like a shiny toy, because I think it needs to have a lot more abilities that in general the systems right now have in AI, like for example abstract thinking, which is not as common, like creativity, or if you talk about motor skills, natural language understanding, transfer learning. So these things, like it's not as commonly used as like as we maybe think or we want it to at the moment, I think. So yeah, I think it's still a shiny toy out there. We do have some examples, like if you look at chatbots or Siri. So they are like, but still they also are most of weak AI out there. I think it's still, AGI is still like a shiny concept right now, a shiny toy, which we need to put in a lot of effort. And in my opinion, when it comes to AGI, it needs a lot more interaction between computational neuroscientists and like the developers, the people who like actually work and develop on the model as well, because yeah, it just needs to. And I also think that when we come to a point which is close to AGI, or like a model which can abstract, which can think abstract, which is like more creative sensory perceptions, etc. I think at that point a concept of artificial empathy is also very important in order to distinguish between like the options, the choices of its making, and how it's going to affect like the end user, for example. um, because I think when we come close to AGI, it possibly could be useful, like very useful to medical cases. For example, like I came across a study some time back, which was how artificial empathy could be very useful in treating patients, for example, with dementia, like how AGI could provide care to them. And because it's like extremely draining for the nurses or for the caretaker in general, so their AGI could come into place. But then there needs to be a very strong angle of artificial empathy, and I think it's still a little too far. But obviously a lot of work is being done, and maybe we see it sooner than we expect. But right now a lot of work needs to be done in
Yep,
my.
yep. Speaking of evolution, right? Speaking of evolution of AI, where do you see we're gonna go and what's reachable within, let's say, 5 years?
When it comes to evolution of AI, uh, I think one thing is that we have come very far from maybe what we would have expected. Like I think when I was in my school years, and I came across the concept, and I'm like, okay, this sounds very interesting. And there wasn't a lot of material out there. Right now, like if you want to build a basic model, you basically have everything available on the internet, starting from the algorithm to the data set, and any help you need within that. So that's really amazing in my opinion. And I think in the future, artificial intelligence will definitely help a lot of industries. Like, um, if you talk about healthcare, for example, healthcare is actually one of the very prominent reasons of why I was interested in artificial intelligence to begin with. Like, that's also something that I really, like, enjoy working with, and I think it's very crucial. And technology can be like, or actually already is a major game changer in the field. So there are, like, I was working with computational neuroscience as my bachelor thesis, and there I worked on BCP and an algorithm, which is like Bayesian propagation, confidence, like neural network kind of thing. And it works within like recurrent neural networks and transfer learning, like deep learning algorithms. So those algorithms, if we, like, work with them in more, I did a lot of the work in abstract condition, but if you do a lot of that work in real conditions, for example, it can even help you like detect if someone's suicidal, or like help with schizophrenia or some other disorders. So like, if I look at those things, it's definitely very promising, and I think it looks good. So the evolution definitely is really good. And yeah, like, different solutions, like, I think I came across a solution from Path AI, and they right now develop these machine learning technologies and tools which assist pathologists to make like more accurate diagnosis, which is very useful because these can help in reducing errors in some like major diagnosis like cancer, or some neural disorders that are pretty difficult to detect. And yeah, like, and for example, like, even recommendation of drugs or treatments, like a preliminary way of determining, and the diagnosis, like early diagnosis. So yeah, like, if we look at that, it's pretty promising.